Okay, now we can extend our knowledge to three dimensions in geometry. Okay, so I want you to take a look at some of the examples here in 3D shapes and think about each of these objects, whether it is a sphere, pyramid, cube, prism, or cylinder. Okay, take a look, and I want you to classify each of them by considering their faces, edges, and vertices. So faces are the flat surface, right? Edges are where two faces meet. So for example, in this cereal box, we can see that edges are here, there. So these are the edges. And vertices where the edges meet. So those points are the vertices, right? So take a look at each of these objects and think about the names of each 3D shape and the attributes in terms of faces, edges, and vertices. What do you see? So what do we call the ball? Here, there, and that apple. These three are called, it is not exactly sphere, but pretty much sphere kind of shape, right? Where there's no vertices, there's no edges or faces. This is just, what is this? Cone, right? We see the cone here. So we're gonna talk about that too. And cube, another cube, sphere, cylinder, prism, rectangular prism, cone, cylinder, and so on and so on and so on. Pyramid, rectangular prism, and so on. Okay, so what are the vertices again? The vertices are the points where the edges meet, and the edges are the line segment where the faces meet, and the faces are two-dimensional, right? Okay, so I have the definitions for each vertex, face, and edges. You need to know what that means. Okay. What is a simple closed surface? Simple closed surface, it's simple. So there's exactly one interior, what's inside, and has no hole, and it should be hollow. Okay. So the simple closed surface separates space into interior, inside, surface, and the exterior. What I mean hereby is take a look at, let's have that prism again. I mean the rectangular prism here. If this is very, very clear instead of the cereal box, let's suppose it's very, very clear, then we can see what's inside, interior, and these surfaces, the faces and edges and vertices, right? That's the surface, and what's outside. So it makes three different spaces: interior, surface, and exterior. So it makes sense, right? And the set of all points on a simple closed surface together with all interior points is solid. There's exactly one interior, there's no hole, and hollow. Okay, so take a look at these examples and consider which one is a simple closed surface and explain why. So have some moment to examine all 6 of these examples. Okay, what is this? Is this simple closed surface? It is because it is solid and there's exactly one interior, there's no hole, and it's hollow, right? Same for this, same for this, same for this. How about this one? It's not, because it is hollow. I mean, it is not hollow, there's a hole, right? There's a hole, so it is not simple closed surface. How about this one? It's not either a simple closed surface, because you can have two interiors. We need to have only exactly one interior, right? So as you can see, these two are the examples that are not simple closed surface. How about sphere? Sphere is a little bit different because it's a set of all points at a given distance from a given point, and you don't see any vertices. Same for cylinder, right? So sphere is a special three-dimensional shape which is not from polygons, right? Because there's no point, there's no edges. Okay, and think about a circle in two-dimensional. What's the definition of a circle? Circle from one center, there's a center point, and equidistant points, all collection of equidistant points. So I'm thinking about this as a flat surface, so circle only, not the sphere. Then there is a center, and from center to the all equidistant points, if you connect them, it will be circle. Similarly, sphere, from at a point, the center point, collection of all points that are equidistant from that center in three-dimensional, it is called a sphere. Okay? All right. What is polyhedron? Polyhedron is a simple closed surface made up of a polygon as the regions of faces. So we are using the surface with polygonal regions. What is a polygon? Polygon is polygon, many angles, right? And it has to be closed and has to have straight line segments. So if you have a circle shape, it's not gonna be polyhedron, right? So polygon is for two-dimensional. If you combine two-dimensional polygonal regions or faces together and create a three-dimensional shape like this, it becomes polyhedron. Okay. The plural form of a polyhedron is polyhedra. So these are the examples of polyhedra. It is called a cube. Cube has all equal size of faces, and each side, S-I-D-E-S, each side is a square. Okay. Triangular prism, you have two faces that are congruent with triangles, congruent triangles, and the sides all around are rectangles. So it is called triangular prism. We're gonna go a little bit deeper about the names. Dodecahedron has 12 faces. Okay, and each face has shape of what is this? Pentagon, right? Because it has 5 sides of polygon. Okay. All right. So we're gonna talk about a little bit more about those two later. I want you to think about some solids that are not polyhedron, which means it is not simple closed surface made up of polygonal regions or faces. So think about those has circle or has no flat polygonal regions of faces, like cones, spheres, cylinders. They are not polyhedron because their faces are not polygonal, right? The vertices of the polygonal regions are the vertices of the polyhedron, and the sides of each polygonal region are the edges of the polyhedron, right? So when you're looking at this example here, we can see the vertices here, all the vertices in the polygonal regions in the triangle vertices, and the vertices of this rectangle, they are also vertices of polyhedron, right? And the size of each polygonal region, so take a look at this triangle and the sides, there are 3 sides. These are the edges of a polyhedron. Same for this rectangle shape. The edges here in the polygon are the edges of the polyhedron. Okay, so that makes sense. Prism. Let's talk about prism. We need to consider what makes prism. What are the attributes of the prism? Prism is polyhedron in which 2 congruent faces lie in parallel. So I lie them down here. You can set it up vertically too. It should be the same thing, right? Because how I put in it's just different. So we can see that there are two faces. This face and that face are congruent. These two faces are congruent, and also this top face and bottom face are congruent, and front face and the back face are congruent. So prism has two congruent faces lie in parallel, right? Especially if it is a rectangular shape, we call that rectangular prism, and we consider these two bottom bases. Bottom bases are congruent and they are parallel. So if we extend this bottom, the base, and this base extended in all direction, they never meet. They are parallel. Okay? And how do we name the prism? It depends on the shape of the bases. So for this one, we have a base of rectangle, so it is called rectangular prism. How about this prism? We have two faces, so two bases that are shaped with hexagon. So we call this as hexagonal prism, right? These two are parallel bases, hexagonal prism. For this one, pentagonal prism, right? We have two congruent faces that lie in parallel. Okay? And those bases and other faces all around the faces, as you can see, the faces are always rectangle shape. If it is right prism. If it is oblique prism, so you can think about this is slanted a little bit, then we're gonna have the faces around those two bases are parallelogram, right? Then it will be oblique prism. Okay? All right, so here are more examples. Here, right triangular prism. Why is that called the right triangular prism? Because it has triangles as the bases, right? And it is right because the angle from the base, the bottom or top, and the faces, lateral faces are they are meeting at 90-degree angles. So the bottom, the blue triangles here, and the faces, the white ones, are meeting at 90-degree angles. Then we call that right prism. If it is oblique, it will be oblique. So the face here in blue and the white lateral faces, they don't meet at 90-degree angles. Okay, then it is not right prism. Okay, again, these two are right prism, right prism. How do we name it though? Depending on the shape of the bases. For this one, it is quadrilateral. We don't know any other things, whether these two are parallel or not. If these two are parallel, you can name it differently, but all four sides of polygon, we call that quadrilateral. So we can say this is right quadrilateral prism. Why do we say right? Because the base blue and the white faces, lateral faces, meet at 90-degree angle. Same for this one. Okay, it's right because the base and the faces meet at 90-degree angle. It's hexagonal because we have the bases with the hexagon shapes. Okay, how do we draw prism? Okay, let's practice how to draw the prism here a little bit. So if we want to draw pentagonal prism, for example, you can start from the bases. You're gonna draw pentagonal shape. Well, I can actually use this pentagon. I don't have a pentagon. Never mind, I will draw it then. Okay, so pentagonal prism, I can start from, oops, I need to connect this. Okay, I can draw okay, let's see. Why it's not working? I will just use my cursor. It's not working somehow. I will figure it out. Anyways, you can draw pentagon that are congruent. So if you draw one pentagon here and another pentagon anywhere, but it has to be congruent. So exactly same size and same shape. Suppose they are same. And then you can connect those corresponding vertices. So this point is corresponding with that point, so connect it. And this with that, they are corresponding, so connect it. And this will be connected with this point, right? And it's inside. I'm using my mouse here, and it's really hard to draw that. I need to have this connection better. I don't know why it's not connected. Something's wrong. Okay, it's not working. But anyways, you can connect, corresponding vertices. So this will be connected with this part. Then you can draw prism. Mine is really bad, but I will try to make it better. Okay, so that's how you can draw the prism. Okay, so you're gonna start from both bases, then connect the corresponding corners. Okay, then you can draw a prism. All right, now let's talk about pyramid. What is a pyramid? Pyramid is a polyhedron determined by a polygon and a point not in the plane of the polygon. So you have a polygon, right? So triangular pyramid, for example, has triangle base. And there's a point that is not on this plane, so outside, and we call that apex. From there, you can have bases that are connected with this base, right? So we call the polygonal region as the base, and the point that is not on that base, apex, and there are lateral faces that are triangular shape. Whichever pyramid you have, the faces are always triangle. It's similar to prism, but prism, the lateral faces are rectangle or parallelogram, right? It depends whether it is right prism or oblique prism, right? But it's always quadrilateral. The lateral faces are quadrilateral in the prism, and in pyramid, the lateral faces are always triangles, right? Like this. We can see the base is square, and the point outside of the base, that apex is here. And we can see the faces that connect apex with the base are always triangle. But the name of the pyramid is from the shape of base. Base is square, so we call this as a square pyramid. This is a triangle, so it's a triangular pyramid. The base is pentagon, so it's a pentagonal pyramid, right? And what is altitude? Altitude is the height, direct height from the apex to the base. So think about you're gonna drop a weight with a thread, attached to it. If you drop it, it's gonna make 90-degree angle with that height and the bottom, the base. So we call that height as altitude. Okay. Okay, so if the pyramid is right pyramid, then the apex is directly above the center, right in the middle, center of the base. If you drop the weight and it doesn't fall right in the middle of the base, then it will be oblique, right? So it's not right pyramid. And what is regular pyramid? Regular pyramid is when you have regular pentagon as the base. For example, square is regular quadrilateral because all four sides are congruent, all four angles are congruent, right? In that case, it's regular pyramid. If it's a regular pyramid, it's always right pyramid too, because it will drop off right in the middle, okay? If the base is triangle, like triangular pyramid, it has a special name, tetrahedron. Tetra means four, hedron means faces, so this one has four faces, right? Okay. All right. So tetrahedron is all faces that are congruent, and all of the triangular faces, lateral faces, or the bottom, the base, all are equilateral triangles. Okay, I think we covered all that here. Okay, let's talk about regular polygon one more time. A regular polygon is polygon, regular. Remember, in the polygon, it's equal angular and equilateral. So all the angles are congruent and all the sides are congruent, the same length, right? And also, we know that a regular pyramid is a right pyramid, so it forms a 90-degree angle whose base is regular polygon. Okay, so let's remember that. And how do we draw pyramid? This is really bad prism, but we can draw pyramid too. So when we draw a pyramid, what we need is, we need to have the base. So for example, if we are drawing triangular pyramid, you can draw a triangle first, right? And draw a point outside, it will be the apex, and connect all other vertices with that apex. So connect it. And connect it. So something like that, that will be a triangular pyramid. I can draw a square pyramid. So I can make a square. But since it should be three-dimensional, it doesn't look like exactly square unless you saw that from the top. Then you can connect it like this, right? Otherwise, if you are looking at that from different angle, it looks like, well, the base can look like parallelogram like that, and there's a point, apex. You can connect all, vertices with that apex. And of course, you can draw these as dotted line. Then you can draw a square pyramid, and so on and so on. Okay, so that's how you can draw the pyramid, right? You start from the base and have a point and connect all of the vertices with the apex. Then you can draw pyramid. Now let's talk about regular polyhedra. So regular means all of the sides, the faces are regular polygon. Regular polygon means you have same sides, the same length, right, and same angles, right? So for example, tetrahedron, tetra means four, hedron means faces, four faces. You have four faces there, they are all congruent, and all of those faces are regular polygon, especially this one is equilateral triangles. Equilateral triangle here, equilateral triangle here, and equilateral triangle at the bottom. Okay, cube has 6 faces, so its another name is hexahedron. Hexa means 6, right? Hedron means faces. So hexahedron is a cube where you have all equal sizes and shape of square on all 6 faces. Okay, octahedron, octa means 8, so 8 faces. When you have 8 equal sizes polygon, congruent regular polygon, then it is octahedron. So we have 8 faces. And when you have 12 equal regular faces, it's called dodecahedron. When you have 20 faces, it's called icosahedron. Okay, let's talk about them a little bit more. So how many faces are there determines the name of the polyhedra, right? So if it has 4 faces, tetrahedron, 6 hexahedron or cube, 8 octahedron, 12 dodecahedron, 20 icosahedron. And you can sketch that to have 4 faces. Each bases have shape of equilateral triangle. For cube or hexahedron, you have square, 6 squares as the faces. Octahedron has 8 equilateral triangles. Dodecahedron has 12 regular and congruent pentagon. Icosahedron has 20 equilateral triangles as the bases. Okay, and you can also open them up, then you can have the net, right? So these are just one example of net. There's not only one way to cut this up and open it up, but these are the examples, right? So if you count the faces here, we can say 1, 2, 3, 4, and all of these faces are congruent, right? And they are all regular polygon. So you can see all of these squares are regular and they are congruent. Same for these, right? Okay, so we can talk about number of faces and their names and their sketch and the net of each regular polyhedra. Here's another example of a patterns for constructing polyhedra. I cannot show you how I can fold this up here, but I want you guys to consider what is each of this net will be if we fold them up. So think about it, and I think this is also in our notes, so print that out and cut them out to fold it and to see what shape you get. Okay, and I want you to pause the video and think about each of these. So if you use your imagination or actual cutouts there, this will be rectangular prism. So you can see these two are the bases and these are the lateral faces, right? So it looks like a box, flat box, right? Rectangular prism. How about this one? We see that all lateral faces are triangular, and this will be the base, and these 4 corners will meet as an apex, so it will be a pyramid. And what is the base's shape? It's a square, so it will be square pyramid. Okay, how about this one? I want you to really cut out this and make a shape of it. It will be right triangular prism. So you can see that these two are the bases, and these 3 rectangles or squares are the lateral bases. Okay, so you can see it is right triangular prism. Okay, all right, so here is another thing for matching. You can have some fun with this matching game. Corresponding polyhedron and the name of a polyhedron for each of them. So A, what is this? It will match with 3 or 4. We know that it will be a pyramid, right? But the base is square, so it will be 3, right? So a square pyramid. How about this one? It will be a rectangular prism, right? Rectangular prism where the bases are square. So we can say that as a square prism too. How about C? Tetrahedron. Oh, here, tetrahedron. All 4 faces are triangle. All 4 faces are equilateral equilateral triangles. So this one, tetrahedron. How about this one? It will be prism, especially the bases are triangle, so triangular prism, right? And the lateral faces are rectangle, right? And this one has 1, 2, 3, 4, 5, 6 squares right? 6 squares is cube or tetrahedron. Hexahedron. Okay, are we good? All right, and I want you to practice a little bit more. So again, hexahedron or cube, and we have tetrahedron, right? And this is octahedron because we have 8 equal faces. And this one, dodecahedron, we have 10 and 11. 1, 2, 3, 4, 5, and 6, and 6 faces. They are all congruent, pentagon shape, pentagonal shapes. Okay, dodecahedron, and we have 20 triangles that are congruent. So icosahedron, right? Okay. Now let's consider regular polygon and the measure of an interior angle. Think back about the sum of the polygons interior angle for equilateral, regular polygons interior angle. What was the formula for the sum of the interior angles of regular polygon? It was 180 times n minus 2, right? So let's go back to the previous lesson. We know that the sum of interior angles of regular polygon, meaning regular polygon has all same length and same angles, like equilateral triangles where you have same sides and same angles, or square where you have the same size and same angles of 90-degree angles, or the pentagon with same size or equal length and equal angles in all of these, and so on and so on. These are regular polygons. Sum of interior angles of regular polygon, we already worked on it. If you don't remember that, go back to that lesson, okay? And minus 2 times 180, right? Then how do we find each angle? Well, we can divide, for this, we can divide this by number of angles, right? Number of angles. Then we can find each of that angle, because they are all equal angles, right? So each angle of regular polygon will be each angle n minus 2 times 180 over n. Knowing that, we can figure out each of the angle for regular triangle, square, regular polygon, pentagon, regular hexagon, and regular heptagon. How? For triangle, we know that the sum will be 180 and divided by 3 will be 60. So each one will be 60. This is a 60 degree, that's 60 degree, that's also 60 degrees. So when you add them together, it will be 180. It's the same as this one. 3 minus 2, 1. 1 times 180 divided by 3, 60. Same for this one. There are 4 angles, so 4 minus 2 is 2. 2 times 180 divided by how many angles are there? 4 equal angles. So if we divide it by 4, that will be 90, right? So each angle is 90-degree angles. And for pentagon, there are 5. So 5 minus 2, 3. 3 times 180 divided by how many are there? There are 5 equal angles. If you do that way, 180 divided by 5, 5 times 3 is 15. 30 left, 6. 36 times 3, 108. So each angle will be 108-degree angle, and so on, right? So we can find the measure of interior angle for each of those regular polygon shape, right? Okay. So in this table, you can see measure of interior angle for each polygon, and we know the number of polygons at a vertex. Okay, so we are extending regular polygon to regular polyhedra. Okay, so these shapes will be our one of the faces of a polyhedra. For tetrahedron, if you have 4 of them, number of polygons at one vertex, we have 3 faces meeting there, right? So there are 3 of them. And for this one, at this vertex, we have 4 faces. And each angle there will be 60-degree angles because we have a triangle there. Triangle, 60 degrees, 60 degrees, 60, 60. Equals the same thing. But we have at one vertex 1, 2, 3, 4, 5 faces at one vertex. Okay, so we understand what it means. So some of the angles, we can just multiply them together to find it, right? And so on and so on. Okay, so that's what it means. You don't have to remember all that, but just to know how you can find measure of interior angle and how many polygons at one vertex. How many polygons at one vertex? At one vertex, there are 4 faces, and so on and so on. Then you can find the sum of the angles by multiplying them together, right? So that's what it is. And here, in this table, I want you guys to explore the 6 polyhedra listed below: tetrahedron, cube, octahedron, dodecahedron, icosahedron. We have been looking at this, right? So have some time to examine this and complete this table. Okay, so let's do this together. What is name of each face? Here, name of the face, triangle. So it's triangle. I will just draw it. You write it, okay? How about the cube? What's the name of each face? Each face is square. Square. It's triangle, but especially it's equilateral triangle. Equilateral triangle. How about this? It's also equilateral triangle. And this one, it's pentagon, especially it's regular pentagon. Regular pentagon. Pentagon. And it's also equilateral triangle. Equilateral. Okay. Number of sides of each face. Each face has how many sides? 1, 2, 3, because it's triangle. There are 3. And square has 4 faces. And triangle has 3 faces. Pentagon has 5 faces. And icosahedron triangle has 3 faces. Number of faces. How many faces are there in total? We have 4 because it's tetrahedron, right? 4. It's a cube. We have 6 faces. Octahedron, 8 faces. Dodecahedron, 12 faces. Icosa, 20 hedron faces, right? And number of vertices, how many vertices are there? 1, 2, 3, 4. So there are 4. Cube has 1, 2, 3, 4 on top and 4 at the bottom, so total 8 vertices. Octahedron, we have 1 at the top and 1 at the bottom, and all around there are, how many are there? 4, so 4, 5, 6, so 6 vertices. How about dodecahedron? How many vertices are there? If you count all that, there will be 20 vertices. And icosahedron, you have 12 vertices. What? That's it? It cannot be. I think I put the wrong number there. How many did you find? Hold on. Yeah, there are 12 vertices. Okay, 12 vertices. How about number of edges? How many edges do you have? 1, 2, 3, 4, all of that. If you count them, there are 6 vertices, 6 edges, 12 edges, 12 edges, 30 edges, and 30 edges. So from here, what can we deduce? What pattern do you find? Can you add the number of faces? can you add the number of faces and number of vertices? So add these together and then subtract number of edges. Okay, and let's see what we get at the end. Okay, so 4 plus 4 is 8 minus 6, 2. 6 plus 8, 14 minus 12, 2. 8 plus 6, 14 minus 12, 2. 12 plus 20 minus 30, 32 minus 30, 2. 20 plus 12, 32 minus 30, 2. So we can see that no matter what shape we get, number of faces plus number of vertices minus number of edges is always 2. We can conclude it. Okay? So remember this. Number of faces plus number of vertices minus number of edges equals 2. That's what this activity is about. Okay, that's what we have noticed. Okay, now let's talk a little bit more about the nets. Okay, I'm going to show you geometric solids here in Illuminations of NCTM website. It's pretty cool. So we are given the solid here. This is a cube, and the net of the cube, ta-da! It shows, right? And we can also show octahedron with a solid shape, and you can show the net, and you can play with f plus b minus e there too, right? So play with that with your students. I think it's gonna be very cool. Okay, in NCTM website there's a classroom resources and in Illumination there are so many interactive activities that you can do with your students. Okay, now let's move on to the cylinders. Cylinders are not polyhedron because the bases, as you can see, bases are not polygon. Circle is not polygon, right? So we know that it is not polyhedron, and the bases, as you can see, they are circles. So if the base is a circular region, we call that circular cylinder. Okay, if line segment forming a circular cylinder is perpendicular to the base, meaning if you drop the weight directly down, then it's gonna form 90-degree angle, and it falls right in the middle of the bottom base, then it is right cylinder. It will be right cylinder. If not, so you drop it, and where does it land? Here. It's not in the middle of the center. It's not the center of the bottom circle, right? It drops down here. Then it will be oblique cylinder. Okay, so pretty easy, right? The height is when you drop down the weight from the circle, center of the top base and forming 90-degree angle, that will be the height. It is very important to find the volume of the cylinder. Okay, so the net for cylinder will look like this. How do we find the height and the length here? Well, height is already given to us, right? Height, we can find it easily. How about the length of this rectangle? That's same as the length around this circle, right? Which is 2 pi r. The length around the circle is called circumference. So this length is the same as the length around this circle, circumference, which is 2 times pi r, or pi times d, diameter, right? Because diameter is the same as 2r. Diameter is from one point on the circle passing through the center and go to the other side, right? So it's just double of the radius. Okay, so 2 times r is same as diameter, right? So 2 pi r is the same as pi times d, pi times diameter. Okay, so we can find the length here, and we can easily find the surface area. Surface area will be h times 2 pi r plus pi r squared plus pi r squared, right? Okay, we can always extend it. And the obliques, circular cylinders net will look like this. A little bit weird, isn't it? Okay, and now let's talk about the cone. Cone is not also polyhedra because the base is circle, right? It's not polygon. It's not straight line segment. So it is not polygon and a point in the plane of the curve. So similar to pyramid, the point is outside of this surface, and we call that vertex. And altitude is the height, so directly down to form 90-degree angle, that is the height. If we can drop it down, drop the weight down, and it lands on the center of the circle, it will be right circular cone. If it doesn't, so you drop it and it doesn't fall in the middle of the circle, then it will be oblique cone. It makes sense, right? Okay. Cone's net, you can see we can have this shape or that shape. It's a little bit more flatter and that's sharper. We can see that. Okay. And from the homework, we have these examples. So I'm gonna go over a little bit on these problems with you guys. The following figures represent cards attached to a wire. So you have a triangular card attached to a wire. And for this card, I am going to rotate that, right? If the card is attached to the wire and if I rotate that, how does it look like? It's gonna look like a cone because I can draw it here. So, okay. Here is the wire and we have a triangular shape of a card attached and we are rotating it. Then you're gonna have this part is rotated, this part is also rotated, this part is also rotated. So exactly similar, but it will be cone shape like this, right? Okay. So that will look like the cone. Okay. How about this? If this card is attached to wire and we are rotating, then it will look like two cones, right? Top and bottom. So we can see that it looks like an hourglass or sand glass, right? So if you have triangles like this, two triangles, we can rotate it here. And we can rotate this here too. So it looks like hourglass. Okay. Can you name the polyhedron that can be constructed with this net? It will be, the bottom is pentagon and we have a triangular lateral faces, so it will be pyramid, right? So it will be pentagonal pyramid, especially this will be right pentagonal pyramid because we see that it's equilateral, right? So it's regular pentagon and all of these triangles are congruent and they are equilateral triangles. So we can say it will be right pentagonal pyramid. Okay. For this, can you find v plus f minus 2? Without even examining, we know that it will be 2. But let's examine that. What is vertex? How many vertices are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 plus how many faces? We have all around 4, 5, and 6, and we have one more here, 7. So 10 plus 7, how many edges? 1, 2, 3, 4, 5 on the top, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So what do we have so far? 10 plus 7 minus 15. 10 plus 7, 17, minus 15, 2. So B plus F minus E is again 2, even if it is not regular polyhedra. Okay. Can you describe the cross section of the figure to the right? If we cut that up, what do you see on this surface? The cross section here will be rectangle shape, right? Okay, so that's all for this chapter, chapter 11, and come on and work on all the problems on the review. Okay, have a good day.